Hello guys, welcome back to my channel. Today we'll be testing this piece of equipment that just arrived. It's called the Schmidt Hammer. It's a concrete testing tool. If you are into any concrete or civil works, it tests the strength of the mixture of the concrete in a rebounding manner. And we're going to be running a test on this for you all to see. First, I have a block wall that I would like to test it. I have a over-cured concrete walkway and a concrete base, a concrete interlock, and then some other testing parameters around. So on the wall, the way to test it is you push it down and you feel the impact of the rebounding hammering to test the strength. I don't know if you can see my calibrations here. Can you see it? Okay, thank you. So I go down. So it's now on 0. Now I want to test it. I go down, I push, you hear the sound. Aha. Then I lock it with the push button that is by the side. So what do we have here? It gave us a rebound of, this is 14 on this calibration on this side. 14. You can take up to 5 sample hammering along the block wall for it to get an average reading. I test again on this side. Yeah, I still have 14 on this side. Of course, this is a block wall. Now I move my test to the concrete floor that has been done for a very long while. You can see the granite still exposed in some places. So we'd like to see the difference between the block wall and the concrete wall. So here, I test here, I lock it. So what do we have here? Wow, this has given us 18 as against 14 we had on the wall. This is 18. Let me try another surface around it. I go now. Whoa. On this side, I have 22. 22. You can see the reading here. 22. So I do one more here before I move to another concrete surface. On this side, 24. So the strength of this concrete is far above what I have on the concrete wall. Now, this is a concrete base. It looks like a street light base or one of the um, tower base, like a plinth for the tower. So I'll free this up again and I want to test the rebound strength. My first reading is giving me 24. 24. I come to another point. What? This is 40. 40, no. Let me test here again. In fact, I can literally see the impact on the surface. Try it again on this side. No, okay. This is 26. 22. 22. And one more check around here. 24. Okay. So this is giving us a similar reading like the concrete surface. Now I come to one more point, which is the interlocking ties that we have here. the paving stone. Mm. Yeah, this is very poor reading. And just because paving stone don't really come with any reinforcement, and that's all I'm getting here is just 12. You can see it clearly, just 12. So, what other surface can we check? Oh, people have there. We want to check on the concrete poles that we use for our outdoor aerial installation. We want to compare the strength to what we have on the walk on the floors we have within the premise. And then we can pick on the standard strength we ought to get from those poles as a quality construction versus the actual output of cast that we have on the floor. So out here we have 8-meter poles for area deployment of telecom cables, and want to see the strength because we have issues where in the process of conveyance the poles get cracked, in the process of installation pole get cracked, and we are locked in between. Is it a case of careless installation or a case of a poor quality fabrication or construction rather? So this tool is going to be helping us to clarify such argument as to why there is a product failure on that concrete. So I'm doing my first test on this. I release it. So let's see the rebound. Am I having 32? I go to the base. I have another 32 here. I lock it. With this button, once you've taken your reading and you want to move the hammer away, you use this button to lock it down so the reading stays. Otherwise, this will retract out. So I go somewhere in the middle of the pole to check again. I release it first, then I take the reading. This is 28. This is 29. And then I'm now to what you do of the concrete. This is 28. So for this particular concrete, it has maintained a concrete strength of 28. Yeah, after the video, I'll be confirming what the standard strength should be to qualify it for a quality cast. I come to another pool different from this and want to compare our reading. They're expected to have similar reading because the mix ratio ought to have been the same. Okay, I have 32 on this. Thirty-two again, right? Yeah. 32. So this poll consistently give us 32 in his reading. So I check one more poll and I check one handhole we have around us. 34, 34. Let's check this sound. First on the cover. 28. The mixture here is poorer. I have 18. Let me check. 22. I'll test it again. Wow. So it shows this sound does not have uniform quality cast. At the edge here, the cast here has a good quality. You can see the reading is 28 on this line. And on this side, I even have as high as 32. But over this side where we have the crack, as you can see on this cover,